All right, so I copied this table on the right here from further down in the notes, but essentially what this table tells us is the z-score is how many standard deviations I am away from the mean. So 0 is the mean, the average itself, and that's the 50th percentile, meaning 50% of people are below the mean and 50% of people are above the mean. If I look at the -1, that is 1 standard deviation down. And then this is the percentile that is. So the area before that is 15.87. And then the area after that is whatever 100 minus 15.87 is, because it's a percentile, so we subtract from 100 as a whole. But we're going to use that in just a sec. So take a look over here. Vending machines can be adjusted to reject coins above and below certain weights. The weights of legal US quarters are normally distributed with a mean of 5.67 grams and a standard deviation of 7/100 of a gram. But the extra zeros means they're that precise. So we could say it's 710 thousandths. If a vending machine is adjusted to reject quarters that weigh more than 5.81 and less than 5.53, what percentage of legal quarters will be rejected by the machine? Okay, so what we're going to do to answer this, to get the rough answers, is I'm going to draw a bell curve. Okay, let's see if I can doodle. Yeah, not bad. All righty. So our middle value is the mean. So this is 5.67 grams. Then I want to figure out what's my 1 standard deviation down and 1 standard deviation up. So 5.67 minus 0.07 is just going to give us 5.60. And then if I add it up, that'd be 14, so carry a 1, 5.74. Now let me write a note about that, type a note rather. So 68% of quarters weigh between 5.60 grams and 5.74 grams. All right, so that's all the numbers that would go in there. And there's an infinite amount of them. All right, now we're going to do it again. What's the second standard deviation? So we're going to subtract off another 0.07. This one is now going to be 5.53. We're going to add a 7 here, and we'll get 5.81. Now look, more than 5.81, less than 5.53. So those are all the ones it's going to reject. What percentage of legal quarters will be rejected by the machine? All right, so our second standard deviation has told us that 95% of quarters weigh between 5.53 grams and 5.81 grams. So if 95% are within those numbers, they're all going to be fine in the machine. So what's the leftover percentage? Well, in this case, we would subtract from 100% one whole. So 100% minus 95%, which is just 5. So 5% of quarters would be rejected by the machine. You know when this was a real problem? Y'all may not remember it, but when the new quarters came out, they weighed less than the quarters that were in standard circulation. And they forgot to make a big announcement they were going to release new quarters. That was a very surprising day in January coming back from this cafeteria. What's this? It doesn't look like real money. It's too clean. That literally, I actually went back and I was like, what the heck is this? And she just said, it's what we got. That's what the bank sent us. All right. So looking at these particular benchmarks that we've seen, the 1 standard deviation up and down, 2 standard deviations up and down, we know those numbers. But what if my number is in between? You know, what if it's 1.5 standard deviations? And I can figure out what that is for this distribution. Like a half a standard deviation would be 0.035. So maybe I wanted to go 1.5 below the mean. So the number would be 5.565, 0.035 minus 5.6. But I don't know what 1.5 standard deviations is for the percentage of the population or the percentile. This is where the z-scores come in. So I could take my negative 1.5 that I was just talking about. Bing. This measures whatever the area to the left is. So it's percentile rank, negative 1.5 standard deviations below the mean. Everybody before that is 6.68% of the population for the normal curve. So with the standard score, we assume the mean is 0. And we say this because the mean is 0 standard deviations from the mean. Then a standard score of a data value 1.5 standard deviations above the mean would be z equals 1.5. And then likewise, if it's below the mean, then we call them negative 2.4, because we're always measuring from our 50% mark as 0. So sometimes we get told the mean, we get told the standard deviation, and then they give us a second value and say, well, how many people are below this particular number in this distribution? But it's not one of the nice standard deviation ways. We're going to use this formula, figure out how far away from the mean it is, and then figure out what proportion that is of the standard deviation. And then we'll look that number up on the table. You do have to kind of keep track of whether it's going to be negative or positive, because it's very easy to swap the difference between the numbers because we just habitually want big number minus small number. If you follow the formula as written, it will work out the positive and negative for you. And then just a definition of percentiles down here. The percentile of a data value is the percentage of all data values in a data set that are less than or equal to it. Same z-scores, a little more bottom. So it's to the left, a standard normal distribution has a mean of 0 and a standard deviation of size 1. We can take any normal distribution and standardize the numbers by using the formula up there, figuring out the difference and figuring out what proportion of a standard deviation it is. And once we do that, it will line up with all these percentiles. Now there is, on the ALEKS calculator, there is this formula. And let's get a real pen. So it is the probability that Z is less than or equal to, and then Alex put a box. So this is, if I figure out what the standard score is, the Z number, for whatever value I'm investigating in the set, I can use this function, and it's on a lot of scientific calculators, to tell me that percentile rank. So if I put in Z less than or equal to -1, it would give me right here 15.87. Although it would probably have more decimals because the calculator has more accuracy. But back in the day before good calculators, you had to go to the table. It's a pain in the butt. You had to go to the table for a lot of things. But we have a lovely calculator, so it makes calculating this, getting a feel for how many people are in a group, as long as you can standardize it, nice. So I yanked this from the book, and then in class I have a set of Alex problems we're going to do. But here, the scores on a psychology exam were normally distributed with a mean of 67 and a standard deviation of 8. So about what percentage of scores were less than 59%? So let's get a feel for where our numbers lie. So our mean over here is going to be 67. And our standard deviation is 8. So if I take 8 off of this, I'm going to get 59. If I add 8, I'm going to get 75. Let me make these numbers a little easier to read. Now, if I subtract 8 again, I'm going to get down to 51. Add 8, and I'll get 83. And we can even do it one more. Minus 8 is 43. And plus 8 is 91. So a tiny, a fraction of a percent will be less than 43 or greater than 91 on this particular psychology exam. So to be able to say this for an exam means like several hundred people took the exam. So one of the, oh my God, giant classrooms, and probably all of the professors' classes put together as one data set. So about what percentage of scores were less than 59? So I know my 59 is one standard deviation down. So based on my 68, 95, 99.7 rule, remember the mean is the 50th percentile. So if I cut my 68% in half, that is 34. So -1 standard deviation is the 50th minus the 34th percentile, which is the 16th percentile, roughly. It's technically a little more exact than that. If we scroll up, it is 15.87 as the actual percentile. So to ask a series of these questions, these were from the book, which means they're expecting you to answer them by handwriting. So your teacher would decide what degree of accuracy you need. On Alex, they will tell you like what to round to. Now here, about what percentage of scores were greater than 83? 83 is 2 standard deviations. So I know the in between here is 95%. And then I have to add the left half of the leftovers. Well, the leftovers would be 5%. So half of that is 2.5. So I have 2.5% from here back. Then in between these, I forget what it comes out to, but we do know that's 34. That's 34. Now the 34, it's not everything to the left. It is just between the two purple lines. It's 34. So if I wanted to know everything from, the left up to -1 standard deviation, well, earlier I did to the 50th minus the 34th to figure out where this number is. But we could also technically look at the area under the curve. And in calculus, there's a fancy function that actually finds the area under the curve. And this is one of its big applications that we never cover in calculus. So you guys are learning something that calc students usually don't know and won't for several years. Okay, so a failing grade on the exam was anything 2 or more standard deviations below the mean. What was the cutoff for a failing score? And approximately what percentage of the students failed? So the greater than 83, there are 2.5% above that. So it's the 97.5th percentile. So the cutoff score for failing, we count the 2 down, is a 51. Then what percentage failed? What percentage are less than or equal to 2 standard deviations down? That's the 2.5%. So the 2.5 percentile ranking. Now, what some professors do is if they teach a large enough section, they make the assumption that the scores will be normally distributed. And then they normally distribute the scores. So with a large enough class and an average selection of students, this is not a bad application. But in most classes, you have it stacked more towards majors within the discipline, which means they're going to score better and it's going to skew the results so it's no longer normal. So that is very often the flaw with doing normal grading is, yes, according to the bell curve, very few people, if you're going to call that second to third deviation an A, very few people would get an A. But if you're not ranking people and you're giving them a different system to go by, you're going to get more over there. All right, so if 200 students took the exam, approximately how many students scored above 59%? Above a 59, sorry. So a 59 was -1 standard deviation. So we have from the mean up is 50, and then we're going to add on that 34. So we get 84%. And there's a number of ways to do this. If I'd look at the z-score for -1, I'd then subtract it from 100% to get 84. So 84% scored above a 59. 84% of the 200 they told us. Well, 84% of 100 would be 84. So 84% of 200 is going to be 2 84s, which is 168. So 168 students scored above 59. Now here they're asking us to do a standardization of the score. This is where we're going to use this weird formula, which I'll just take a little snapshot of and drag it down there. So when they say, what is the standard score for an exam score of 67, we are going to take the 67 as our data value, and then we're going to fill in the mean and the standard deviation in the other ones. So all of these z-scores are going to be insert number minus 67 divided by 8. And with that big divided by, we're going to need some parentheses around the top, or you do it as 2 separate steps. So if I put 67 into the box, let's go ahead and make that a different color. Seriously. There. 67 minus 67 is 0. 0 divided by 8 is 0. So the z-score for the first one is 0, as it should be since that's the mean. Move that over. Now for the 71. 71 minus 67 is 4. 4 over 8 is 1/2 or 0.5. We write z-scores as decimals, not as fractions. So this one is 0.5. So it's 1/2 a standard deviation above the mean. Then if we look at 79, 79 minus 67, that is 12. So 8 and then 4 would be 1/2, so 1.5 above. And now 55. So note 55 is smaller than the mean. So we should get a negative z-score here. So if I'm going to write this one down, my data value that they're asking me to figure out the standard score for is 55. So we're going to have 55 minus 67 all over 8. So 55 minus 67 is negative 12. So the 12 over 8 is still 1.5. It's just now we're going to get a negative. Now, if I wanted to know the percentiles that go with those, well, we know 0 is going to be the 50th percentile. Has to be by definition. Mean is the middle value, is the most frequent value. But 1/2 a standard deviation up up 69.15% of people, their score falls below that mark. The 1.5 is 93.32. Now I want you to note the table, we've got tenths and hundredths going up by 5s up to 1 standard deviation. After 1 standard deviation, it only goes by tenths. The calculator will do the ones in between. To do the ones in between by hand, you would have to look at a z table that had all the values in between, and it's ugly. I mean, it's just a lot of numbers. It's not like, I don't know what it is. It's just, and then down here, our negative 1.5 would have 6.68. All right. So that's enough to get the ideas across. Tomorrow in class, I pulled a bunch of questions from Alex that we can go over, or we can just use someone's account.